Friends, today we are solving Chemistry P1 MCQs from May-June 2025. These questions are very important if you want to improve your paper solving skills and score higher in chemistry. So let's start. Question number 1. At temperature X, the volume of the samples of hexane and pentane are not affected by changing the pressure from 1 atmosphere to 2 atmosphere. At temperature X, the pentane molecules are free to move. That means it might be a gas or liquid. And hexane molecules are in fixed positions, so it is a solid. But since it's written that the volumes are not, their volume is not affected by the pressure, it means that they have fixed volumes, and gas does not have a fixed volume, so that means the option of liquid is correct and solid. So option C is the correct option. Next is that a gas is produced by a chemical reaction at one side of the laboratory. After a few minutes, the gas is detected at the other side of the laboratory. Which process explains why gas is detected at the other side of the laboratory? So the process is diffusion, which means the spreading of molecules from higher concentration to low concentration. Which statement is correct? All compounds are ionic. No, all compounds are not ionic. There are some covalent compounds as well. All compounds conduct electricity when molten. The covalent compounds do not conduct electricity in any form, in molten form, or in aqueous state, whatever it is. Like for example, molten sugar is covalent and it does not conduct electricity. Number 4 is that atoms of element Q form positive ions. An ion of Q has 10 electrons and 14 neutrons. Which statement is correct? Now this element Q, for example, if this is the nucleus, the first shell will have 2 electrons, the next one will have 8 electrons. This is an atom of Q, and if it forms a positive ion, the positive ions are formed by the loss of electrons. That means it must have 1 or 2 electrons in the third shell as well, which it will lose and it will change into a positive ion. So that means that it should have more than 10 electrons. It might have 11 or 12 electrons plus 14 neutrons. So that makes its mass number greater than 24. So it means that option D is the correct option. Okay, number 5 is that which particle contains greatest number of electrons. If you write the atomic numbers for magnesium, nitrogen, neon and sulfur, the atomic number or the number of electrons in magnesium is 12 and 7 in nitrogen, 10 in neon, and in sulfur it is 16. And when these change into ions, like magnesium forms, it gains a charge of positive 2 by loss of 2 electrons. That means this ion will have 10 electrons now. Nitrogen forms nitride ion by the gain of 3 electrons, so it will have a total of 10 electrons. Neon is monatomic noble gas, so it will have 10 electrons. Sulfur, when forms sulfide ion, it gains 2 electrons. So the total number of electrons in sulfide ion is 18, which is the greatest of all. So that means option D is the correct option. Question number 6. Table shows data about 2 isotopes in a sample of element europium. So the relative mass of isotopes is given over there, and the percentages are also given. What is the relative atomic mass of the sample of the sample of europium? Now always remember that the isotope that is present in larger amount pulls the average close to itself. Like for example, if you see the example of chlorine, chlorine has 2 isotopes. Chlorine 35 has an abundance of 75%. Whereas the other isotope, chlorine 37, has an abundance of only 25%. If you take out the average, the average atomic mass of chlorine is 35.5, which is closer to this isotope, which is present in excess, in abundance. So it means that out of these two isotopes, which one is present in more abundance? It is this one. So according to that, our option B is the closest one. Option B will be the correct answer. Now question number 7. Which statement about magnesium oxide is correct? First is that it has high melting point and good electrical conductivity at room temperature pressure. Okay. Next is that it is made up of magnesium anions and oxygen cations. Then C is that it is an ionic compound. It has yes, it is an ionic compound. Magnesium oxide, magnesium is metal, oxygen is non-metal, so it is an ionic compound and has a good electrical conductivity when molten. Yes, so option C is the correct one. We will not select the first one, that it has high melting point and good electrical conductivity. They have not mentioned whether it's in molten state or in dissolved state, so option C is the correct one. Which statement about silicon 4 oxide is correct? It conducts electricity? No, because it is covalent and covalent compounds do not conduct electricity. It has a giant covalent structure. Yes, it has a giant covalent structure. It is an alloy. No, it's not a metal. It is not ionically bonded. Next is, which compound has the highest relative formula mass, or MR? So first of all, we will write their chemical formulas. This is calcium carbonate. Lithium sulfate is this one. Magnesium chloride, MgCl2. Then potassium nitrate. We can calculate their MRs. For example, for calcium, it is calcium 40 plus carbon 12 plus for oxygen it is 16 multiplied by 3, and when you solve it, your answer would be 100. For lithium, it is 7 multiplied by 2 plus for sulfur is 32 plus oxygen is again 16 multiplied by 4. So its answer is 110. Magnesium chloride, magnesium is 24 plus chlorine is 35.5 multiplied by 2, and its answer is 85. KNO3 is potassium is 39 plus nitrogen is 14 plus oxygen 16 multiplied by 3. Its answer is 101. So which is the biggest answer? It is for lithium sulfate. So our option B is the correct answer. Question number 10 is that 10 centimeter cube of ethene is completely combusted in 400 centimeter cube of oxygen. So they have given the volumes of ethene and oxygen in cubic centimeter. The volumes of both gases are measured at room temperature pressure. What is the final volume of the gas in the mixture measured at room temperature pressure? So we can write a reaction between ethene and oxygen. We can write the combustion reaction. Ethene is C2H4. It's a gas. plus oxygen, which is also a gas. And since it is combustion, and in combustion the products are always carbon dioxide, which is also a gas, plus water. Now we need to balance this equation. It is balanced now. Okay, now we see that ethene and oxygen, they react together in a ratio of 1 mole 1:3. 1 mole of ethene reacts with 3 moles of oxygen, or in terms of volume you can write that 2400 cubic centimeter reacts with 7200 centimeter cube of oxygen. Okay, so in the question they have given 100 centimeter cube of ethene, and we have to find, if we have 100 centimeter cube of ethene, it will react with how much oxygen. So take it as x and calculate the value of x. It would be 7200 multiplied by 100 divided by 2400. Your answer would be 300 centimeter cube. And how much is given in the question? How much oxygen do we have? In the question it's written that we have 400 centimeter cube of oxygen. So out of 400, 300 will react, and then how much oxygen would be left behind? Oxygen left behind or left unreacted will be, it will be 400 minus 300. So 100 centimeter cube of oxygen would be left unreacted. The rest of it would react. Now since oxygen is present in excess, our limiting reactant is ethene. So what is the ratio of ethene and carbon dioxide? Since carbon dioxide is also gas, so we have to find out what is the total amount of gases which are present at the completion of the reaction. So ethene, the ratio between ethene and carbon dioxide is 1:2. So you can say that if you have 2400 cubic centimeter of ethene, it will produce 4800 centimeter cube of carbon dioxide. And if you have 100 centimeter cube of ethene, how much carbon dioxide gas would be produced then? So it would be 4800 multiplied by 100 divided by 2400. The answer is 200 centimeter cube. Now we have 100 centimeter cube of oxygen and this much carbon dioxide which is produced as a product. So what is the final gas volume? Final gas volume would be 200 plus 100, so it will be 300 centimeter cube. This much volume would be present after the reaction is completed, or it would be the final volume of the gases. The formula of sodium carbonate with 10 molecules of water is given. What is the percentage composition by mass of oxygen in hydrated sodium carbonate? Alright, so we have 10 molecules of water. What is the MR for water? MR for water is 2 plus 16, that makes 18. Alright, now let's write for Na2CO3 with 5 water molecules, which is the water of crystallization. Now the atomic mass of sodium is 23 multiplied by its subscript, which is 2, plus carbon 12, plus 16 for oxygen multiplied by 3. Then we have 5 water molecules, so that means 5 multiplied by 18, which is the molecular mass of water. When you will calculate it, your answer would be 286. Now we have to find out the percentage of oxygen. Let's see how many oxygen atoms are there. Over here we have 3 oxygen atoms in carbonate, and then how many oxygen atoms are there? Sorry, it's not 5, it is 10. We have 10 water molecules in the formula given. So how many oxygens do we have? 3 over here with carbonate and 10 oxygens in water molecules, so that makes a total of 13 oxygen atoms. Alright, so what is the atomic mass of oxygen? It is 16 multiplied by 13 divided by 286 multiplied by 100. So your answer would be 72.7. That means that option D is the correct answer. Now the next question is that the diagram shows the electrolysis of molten lead bromide. So it is lead bromide. Lead bromide will ionize to form lead ions and bromide ions, alright, with inert electrodes. So which row identifies the particles that carry charge along each arrow? Okay, so in 1 and 2 it is the electrons. These are the electrons which travel through the wire. So 1 and 2 represents the electrons. And then what does 3 represent? This electrode is connected to the positive terminal of the battery. So the negative bromide ions will be attracted towards the anode, and when bromide ions come at the anode, they will get discharged by losing their electrons. They will lose their electrons over here. So 4 also represents electrons. So that makes option C the correct one. Alright, then the next one is question number 13, that what are the products formed at the 2 electrodes when aqueous copper 2 sulfate is electrolyzed using copper electrodes? Now copper electrodes are not inert and they take part in the reaction. So if I make the cell over here, now it has the electrolyte, which is copper 2 sulfate. So there would be copper ions, sulfate ions in it, as well as, since it is aqueous, so water will also split up into hydrogen and hydroxide ions, and then we have 2 electrodes in it. Which are connected with the battery. So it's a positive terminal, this is the negative terminal. So that makes the copper anode, and which is the impure one. And this is the copper cathode connected with negative terminal, and this is pure copper. You also know that this method is used to convert impure copper to its pure form. So what will happen, that this anode, from the anode copper ions will move to the solution, and from the solution these copper ions will move towards the negative cathode. All right, and if you see what happens at the electrodes, I can write the reaction over here. At cathode, what happens at cathode? Cathode has a negative charge, and the copper ions that come over cathode, the copper ions which are present in the solution dissolved in this in water, they pick up, when they come at the cathode, they pick up electrons and they get discharged as copper metal or copper solid. And what happens at the anode? Anode is positively charged, and over here from the anode the copper ions from anode is of impure copper. So from the electrodes these move into the solution as copper ions by losing electrons. Okay, so which is the correct option now? The correct option is A. Okay, that at anode we have aqueous copper 2 ions, and at cathode we have copper metal. Okay. Number 14. Which statement about hydrogen oxygen fuel cell is correct? It uses chemical energy that has only one product. Yes, that's the correct answer, because in this, if I write the reaction, hydrogen reacts with oxygen to form water, and only water is formed, and hydrogen is called clean. Hydrogen is called clean fuel because it does not produce carbon dioxide, sulfur dioxide or smoke. A reaction pathway diagram is shown. Now this is showing which reaction, exo or endo? Yes, this is endothermic reaction. And what happens in endothermic reactions? Bond breaking takes place. If there is a bond between two atoms, this bond breaks and these two atoms split up. Okay, so which option is the correct one? This one. It's a hydrogen gas, and the bond is between these hydrogen atoms is breaking, and the atoms are separating from each other. Atoms have got separated from each other. Which process is a chemical change? Distillation? No, it's a physical change. Evaporation, melting, these are all physical changes, but rusting is a chemical change, because once iron gets rusted, this change cannot be reversed. So it's the correct answer. In question number 17, it is written that aqueous sodium thiosulfate reacts with hydrochloric acid. The rate of reaction increases if the concentration of both the reactants is increased. Nitrogen gas reacts with hydrogen gas. The rate of reaction increases if the pressure in the reaction vessel is increased. Which row correctly explains why the given change increases the rate of reaction? Okay, so in column 1 it is written that increasing the concentration of aqueous sodium thiosulfate and hydrochloric acid. So what happens that when you increase the concentration of the reactants? Yes, this one, that higher frequency of collisions between the particles takes place. So Our correct answer could be A or B. For the next one, let's see. Increasing pressure in the reaction vessel containing nitrogen and hydrogen gas. Yes, when you increase the pressure, then again there are more chances of effective collisions. So that makes option A as correct one, because over here it's written activation energy is decreased. Now we have not added, now in the question we are not given any catalyst, so we will select option A. Okay, now question number 18. Question number 18 is that magnesium reacts with dilute sulfuric acid. The equation is given, and two experiments are carried out at 25 degrees Celsius. In experiment number 1, we have 24 gram of powdered magnesium. It is reacted with this much volume of this much concentration sulfuric acid. And in experiment number 2, we have the same amount of magnesium and it is reacted with this much volume and the concentration of sulfuric acid is given. Now we have to select that during each experiment the volume of hydrogen produced is measured at regular intervals and the results are plotted on graph. Okay, in these 4 graphs you can see in A and B we have over there it's written the volume of hydrogen gas produced. Here we have same volume of hydrogen gas produced in graph 1 and A and B, whereas C and D the volume of hydrogen produced by experiment 1 and 2 is different. Alright, over here the volume of hydrogen that is produced in both the experiments is different. Now we have to see out of these 4 which is the correct option. So we can write the reaction over here, that magnesium solid reacts with sulfuric acid to form magnesium sulfate and hydrogen gas. Okay, since we are performing 2 experiments, in experiment 1 what is the amount of magnesium given? It is 24 gram. And for sulfuric acid the volume is 100 centimeter cube and concentration is 1 mole per decimeter cube. Okay, so in experiment number 2 we have same amount of magnesium which is 24 gram and sulfuric acid is the volume of sulfuric acid in the second experiment is taken 50 centimeter cube and its concentration is 2 moles per decimeter cube. Alright, now we can calculate the number of moles of sulfuric acid. For this one the formula would be moles will be equal to concentration multiplied by volume. Concentration is 1 and volume you have to change it into decimeter cube, so it will be 0.1. So the answer will be 0.1 moles. And over here let's find out the number of moles again. Concentration multiplied by volume, it is 2 multiplied by 0.05 and we get same number of moles. So in both the experiments you can see that we have same amount of the reactants. We have same amount of magnesium as well as the number of moles of sulfuric acid is also the same. So what does it mean? It means that when you have the same moles of acid in both, or same amount of reactants are there, then we will get the same volume of hydrogen gas. It means that we will just cross these two options, because here we get different volumes of hydrogen gases in experiment 1 and experiment 2. Now we have to select whether A or B. Okay, so let's see. Over here, if you see, what is the concentration? Concentration is 1 mole per decimeter in 1 decimeter volume. And over here we have 2 moles per decimeter cube. It's double, 2 moles per decimeter cube. So what does it mean? It means that over here, since over here the concentration is high, so here we have higher concentration of sulfuric acid. So that means our reaction would be faster. So experiment number 2 would be a faster reaction, or you can say the graph, or it will have a more steeper curve. Okay, so experiment number 2 is more faster reaction. Experiment number 2 is represented by dotted line, so its graph is more steeper and it is more faster reaction, so that makes the correct option A. A is the correct answer. Now let's move on to question number 19. Which row gives the catalyst for the two processes? First is contact process. What is the catalyst used in contact process? It's vanadium 5 oxide. That means we have to select out of C and D. And in Haber process, which is the catalyst? It's iron. So that makes option C the correct option. Then the next one is that the diagram shows a change in pH as strong alkali is added to weak acid. Over here you can see the acid is weak, and as we add the strong alkali in it, what happens that the pH goes on increasing. Finally the pH comes over here. Okay, when you just have the strong alkali. So 40 centimeter cube of strong alkali is added to weak acid, and a sample of solution is tested separately with methyl orange. What is the color of methyl orange in alkali? It gives yellow color. And what is the color of thymophthalene? It gives blue color. Okay, because we are over here we are just left with the alkali. We have added the alkali. Neutralization takes place at 7, and after that we just keep on, after neutralization point is gone, we just keep on adding the alkali in it. Okay, we are just adding alkali more and more in it, so the solution becomes alkaline, and the indicators will show the colors which they show in alkalis. So which option would be the correct one? It would be, yes, D. Okay, number 21. The row shows equations for dissociation of methanoic acid and nitric acid. Now methanoic acid is an organic acid, and it's a weak acid. So for weak acids, this is a weak acid. For weak acid, the reaction is always reversible. It's a reversible chain. Nitric acid is a strong acid, and the strong acids ionize irreversibly. So over here option D is the correct one, because this is methanoic acid. It ionizes reversibly, whereas nitric acid is a strong acid and its reaction is irreversible. Number 22. Which statement about elements in the periodic table is correct? A. Across a period, elements at the left side of the periodic table are more metallic than those at the right side. Yes, this is correct, because this is the periodic table. This is the right hand side, this is the left hand side, and we have metals over here. And we have on this corner we have non-metals on the right side. Rubidium and cesium are both elements in group 1 of the periodic table. Which prediction comparing rubidium and cesium is correct? Now in alkali metals, when you have lithium, sodium, potassium, rubidium and cesium, what happens that which prediction comparing rubidium and cesium is correct? That cesium has higher density and greater reactivity. When you move down the group in alkali metals, what happens that down the group, as the size increases, because of this increase in size, the density also increases, as well as the reactivity also increases. So option A is the correct one, that cesium has higher density and higher reactivity. Three statements about halogens are listed. All halogens are non-metallic diatomic molecules. Okay, so this is correct. And then chlorine displaces both bromine and iodine from the aqueous solutions of their salts. Yes, chlorine can also displace bromine and iodine. The halogens become more reactive on descending group 7 of the periodic table. No, these are non-metals, and for non-metals, when you move down the group, the reactivity decreases for non-metals. So that means this one is not the correct option. So that makes option B the correct one. Okay, which statements about neon are correct? It is unreactive. Yes, because it's a noble gas. It has strong intermolecular forces. No, it does not form a molecule, so there are no intermolecular forces between them. They exist as monatomic gases. It has fuller outer shell of electrons, so this one is also correct. So that makes again option B the correct option. Okay. Number 26, substance X has the following properties. Its melting boiling points are given, it's malleable and good electrical and thermal conductivity. What is the structure of substance X? It's a giant covalent, giant ionic, giant metallic, simple molecular. Now if you compare the bonds, metallic bond is the strongest of all. Then comes ionic bond, and then comes the covalent bond. And here you can see that the melting points and boiling points are very high, and it is malleable, and so it makes option C, that it has a giant metallic lattice. Now next question, number 27. Which statement explains why objects manufactured from aluminium corrode very slowly? The reason is that aluminium, a block of aluminium forms a coating around itself of aluminium oxide. It's a tough covering, and it's like, you can say, it's a protective covering that protects aluminium from further rusting. So that makes option D the correct one, that the objects become coated with a protective layer of aluminium oxide. Next is 28. Iron 3 oxide used in blast furnace contains impurity silicon 4 oxide. Which reaction removes silicon oxide? Now we add calcium oxide to remove silicon dioxide. So this is the correct one. Calcium oxide reacts with the silicon 4 oxide to form calcium silicate, and this is formed as a slag which is used in road construction as well as cement manufacturing. Calcium silicate is used. Alright, let's move to question number 29. The domestic water supply is treated before it is supplied to houses. 3 treatments are listed: sedimentation and filtration. This is done to remove all the solid particles, the insoluble solid particles. Chlorine is added to kill the germs, all the germs and microorganisms that are present in water. And treatment with carbon. So carbon removes all the color or any unpleasant smell. So that makes option B the correct one. Okay. Next one is the nitrates and ammonium salts are used as fertilizer. Which fertilizer contains the greatest mass of nitrogen in 50 kg of the compound? Ammonium chloride, NH4, ammonium nitrate, ammonium sulfate, and KNO3. Here you have NH4 Cl. You can calculate its MR. Its MR would be, if you calculate it, it would be 53.5. And the next one they have given, this is option A, and option B is NH4 NO3. If you calculate the MR, it is 80. Option C is ammonium sulfate, and its MR is 132. Option D is KNO3. Its MR is 101. Now we have to calculate the percentage of nitrogen. In 4 of them, over here it has only 1 nitrogen atom, so that makes 14 divided by 53.5 multiplied by 100, it would be 26.2%. And over here the percentage of nitrogen is, there are 2 nitrogen atoms, So it means 14 multiplied by 2, or you can write 28 divided by 80 multiplied by 100. So it would be how much? It would be 35%. Next is ammonium sulfate. Over here we again have 2 atoms of nitrogen in it. So 28 divided by 132 multiplied by 100. Your answer will be 21.2%. And then you have KNO3. Over here the percentage of there is 1 nitrogen atom, so it is 14 divided by 101 multiplied by 100. So it will make 13.9%. So which is the correct one? Which has more? Option B. So the correct option is B. Okay, so question number 31 is, which strategy reduces methane emissions? Flue gas desulfurization, planting more trees, reduction in livestock farming. Yes, option C is correct, because livestock such as cows and sheep produce large amounts of methane gas during digestion process, and methane is a, you know that it's a strong greenhouse gas that contributes to global warming. Now next one is, the compound P is an alcohol with molecular formula C4H10O. How many structural isomers are there of compound P? 2, 3, 4 and 5. So we can make the isomers of C4H10O. C4, the formula is C4H10O. Now we have, first of all, the first isomer will be, we can make it the one with 4 carbon atoms. Okay, and since it's an alcohol, so we have to write OH group along with that. So it will have 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is the 10th hydrogen. So if you number it, this is carbon number 1, 2, 3 and 4. So what would be its name? It will be butane 1-ol, because the OH group is attached with the first carbon. Now we can make a second isotope, and over here we can attach OH group with carbon number 2. Okay, so 1, 2, 3, 4. I can put it the next the hydroxide OH group with this carbon or with this one. If I put it here, then it will be 1, carbon number 1 and 2. And if I write it with this carbon, the other one in the middle, I write OH over here, then I start numbering from this this side, from this end, 1, 2. Again it will make 2 butanol. Okay, now we can just write hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this is the 10th one. Now its name would be butane 2-ol. Now let's try to make another isotope, and now what can we do is that we can reduce the size of the chain, and out of this chain is of 4 carbons. Let's make a chain of 3 carbons, 1, 2, 3, and we can attach the 4th carbon as a group. Again, we will not attach that carbon with the terminal or the carbons which are present on the ends. We will never attach it with the terminal carbons. So we will put the fourth carbon over here with the middle one. So this is the OH group. Okay, now just write hydrogens: 1 2 3 4 5 6 7 8 9, and this is the 10th one. Now we just have to number the carbons. If I number from here, 1 2 3. Okay, so what will be its name? It will be 2-methyl, and the chain is of 3 carbons, so its name will be propane 2-ol. Okay, now what if I attach OH group with carbon number 1? The structure remains the same. Chain of 3 carbons, the fourth one is present over there as a group: 1 2 3 4 5 6 7 8 9. Okay, so there are 10 hydrogens if you count: 1 2 3 4 5 6 7 8 9 and 10. Now if I number it, it will be 1 2 3. So that means it is 2-methyl and propane 1-ol. So that makes a total of 4 isomers. So that means option C is the correct one. Now question number 33. Alkanes undergo substitution reactions with chlorine. Which row shows 2 correct statements about the reaction between alkane and chlorine? So we know the reaction. This is the alkane. It reacts with chlorine. The reaction takes place in the presence of ultraviolet light. One of the hydrogen gets replaced by the chlorine atom and it forms plus HCl. So which is the correct option over here? Option D, that a hydrogen atom is replaced by chlorine atom. Over here, see, the hydrogen gets replaced by chlorine and the reaction requires ultraviolet light. Question number 34. A molecule of compound C4H6 is shown below. This molecule undergoes 2 separate addition reactions. So 2 separate reactions. Addition, since it's a double bond, so always across a double bond addition reaction takes place. Like if there are 2 carbons, one group will add up over here, the other one will add up over here. One atom goes with one carbon, the other one goes with the other carbon atom. Alright. So it undergoes an addition. It goes under addition reaction with excess bromine. So that means that this is one bromine molecule that can add across the double bond. Okay, but in the structure that is given over here, we have 2 double bonds. So that means that one bromine can add up across this double bond, the other bromine atom can add across the other double bond. So you can write that one molecule of C4H6 reacts with 2 bromine molecules. Alright, And when this next addition reaction is that when C4H6 reacts with steam. So when steam means water, and when water splits up, it splits up into hydrogen ions and hydroxide ions. So when hydroxide ion adds, or you can say steam adds across the double bond, what is the product? The product is an alcohol. Okay, so when C4H6 reacts with steam, the product is alcohol. Alcohol is formed. So it means that which option is the correct one? It's option C. Okay, that since there are two double bonds, so they will react with two molecules of bromine, and when it will react with water, the product is an alcohol. Number 35. Which statement about the members of homologous series of alcohols is correct? An alcohol with two carbon atoms in each molecule is called methanol. No, methanol has only one carbon atom. B is butanol can be combusted to give carbon dioxide and water only. Yes, combustion. In combustion, the products are always carbon dioxide and water. Ethanol is the only alcohol that can be oxidized to carboxylic acid. No, all the alcohols can be oxidized to carboxylic acid. Propanol can be made by the catalytic addition of steam to ethene. No, propanol has 3 carbon atoms and ethene has 2 carbon atoms. Okay. The diagram shows the structure of a compound called ethanoic anhydride. 1 mole of ethanoic anhydride reacts with water to form 2 moles of carboxylic acid. Only this carboxylic acid reacts with ethanol to form an ester. Okay, it means that this anhydride, it splits up. Either it breaks from this side or it breaks from this side, and when it breaks, it forms 2 carboxylic acids. Okay, and once these carboxylic acids are made, then they react with the water. Excuse me, sorry. First is that 1 mole of ethanoic anhydride reacts with water to form 2 moles of carboxylic acid. Okay? Means either this or this bond will break, and as a result of it, you will get 2 molecules of carboxylic acid. This carboxylic acid then reacts with ethanol to form an ester. Now you have to write how many moles of water react with 1 mole of ethanoic anhydride, and what is the structure of ester. Okay, so that means we have to write the reaction. Okay, I am going to make the structure of ethanoic anhydride. So when you add water into it, water also splits up, and over here the bond breaks. Let's say this bond breaks, so this carbon will combine with the hydroxide ion. Hydroxide ion will come over there. Over here, this OH group will form a bond with this carbon, and this oxygen, since the bond is breaking between carbon and oxygen, so from water, this hydroxide ion will get bonded with this carbon, and the hydrogen ion will get bonded with the oxygen. As a result of it, we will get 2 molecules of carboxylic acid. See, I am writing the first one. C double bond O, and with this OH group will attach. This is first carboxylic acid, and then for the second one I'm writing the second one. It's oxygen over there. With oxygen, hydrogen will get bonded, and this is the other molecule of carboxylic acid. So we have got two molecules of carboxylic acid. Now when this carboxylic acid reacts with ethanol, it has two carbons, so it is ethanoic acid. All right, so you have to write the ethanoic acid reacting with alcohol, which is ethanol. The question they said ethanol. Ethanol again has two carbons in it. Okay, now what will happen? This is the carboxylic acid and this one is alcohol. Carboxylic acid will lose this hydrogen, and over here the alcohol will lose the hydroxide ion. As a result of it, what is formed? Water plus ester. Okay, and when you have to make the ester, you have to join this carbon, because the bond of oxygen, the bond between oxygen and hydrogen is breaking. So you will just attach this oxygen with this carbon, because over here the bond between carbon and oxygen is breaking. Now you have to join this oxygen with this carbon. Okay, so let's join it. I'm writing the first carbon of carboxylic acid, then CO, then oxygen, and I have to attach this oxygen with this carbon. All right, again this carbon is further bonded with two hydrogens and the other carbon, which is in turn bonded with three hydrogens. Now what is this formed? This is the ester. Okay, so let's move back. Which is the correct option? Number of moles of water. How many water molecules were there? 1. Okay, and structure of ester. That was the ester that I made. Okay, I made this linkage. The bond between carbon and oxygen. This one. The bond between this carbon and oxygen. This linkage. Okay. So this one is the correct option. It was question number 36. Now 37. 4 samples are analyzed using paper chromatography. P, Q and R are pure substances. Pure substances, remember, give only a single spot. And M is a mixture of different substances. So for M is a mixture. Okay, so that's why we will get more than one spots for M. Like see, we have got 3 spots for M. Now we are going to match M with P, Q and R, and let's see what is M made up of. Yes, it matches with Q, it matches with P, but it does not match with R, but it means that it has something else which is not being shown in the chromatogram. There is something missing, some other substances they also there, okay, which is present in M. So which substance that does mixture M contain? option. Which is the correct option? The correct option is B, that it contains P, Q and some other substance which is not shown in this chromatogram. Okay, now question number 38. A student is making a sample of aqueous copper 2 sulfate. The student adds an excess of copper 2 oxide powder to warm sulfuric acid and stirs the mixture. Which apparatus is used to separate aqueous copper 2 sulfate from the excess copper 2 oxide? Burette, distillation flask, apparatus, filter funnel and paper or measuring cylinder. So this is the beaker. It is filled with you can say dilute sulfuric acid, and this is copper oxide. Copper oxide is a black solid that does not dissolve in water. So how are you going to separate it? The reaction will take place between copper oxide and sulfuric acid. As a result of it, you will get copper sulfate plus water. So how will you separate? Which apparatus is used to separate aqueous copper sulfate from excess copper oxide? Since it is not soluble in water, copper oxide is not soluble in water, so you can easily filter it out. So you will use filter funnel and paper to separate copper oxide from the product. 39 is how can a pure sample of barium sulfate be obtained from barium carbonate? Okay, now dissolve it in hydrochloric acid, add dilute sulfuric acid, filter and crystallize. Dissolve it in dilute sulfuric acid, dissolve it in dilute hydrochloric acid, add dilute sulfuric acid, filter and wash, and then dissolve it in water. Now let's see which option would be the correct one. Since if we write the reaction of barium carbonate plus sulfuric acid, the product is barium sulfate plus from carbonate, carbon dioxide gas will come out, plus water. Now remember that barium belongs to group 2 and the carbonates of group 2 are not soluble in water. So solid barium carbonate is first dissolved in HCl because it is not soluble in water, so we cannot make its solution by dissolving in water. We have to dissolve it in hydrochloric acid to make its solution, and then sulfuric acid is added to get the precipitates, and then when we get the precipitates of barium sulfate, these barium sulfate is an insoluble salt. So once we get this barium sulfate, which is an insoluble salt, we can just filter it out and we can wash it. So that means which is the correct option, A or B, because we don't need to crystallize, we don't need to crystallize it. So option B is the correct one, because copper sulfate is an insoluble salt that can easily be filtered out. Okay, the last one, number 40. A sample of white powder X is dissolved in water. Tests are done on separate portions of this solution and the observations are shown in the table. In test 1, add aqueous sodium hydroxide a drop at a time until in excess. Observation is that white precipitates form soluble in excess, giving a colorless solution. Okay, acidify with dilute nitric acid, then add aqueous silver nitrate white precipitates forms. Acidify with dilute nitric acid, then add aqueous barium nitrate. The solution remains colorless. Okay, now you have taken sodium hydro in the first one, sodium hydroxide. You add it in, first you add few drops of it, and then you add it in excess. Okay, so white precipitates form is written that white precipitates form which are soluble in excess. So what can it be? We know that aluminium is soluble in excess sodium hydroxide. But the other option, see the options is aluminium or calcium. But calcium is insoluble in excess sodium hydroxide. So what do we have? Aluminium or calcium? Yes, we have aluminium, not calcium. In the second one, so from test 1 we find that the cation, the positive ion, is aluminium, not calcium. The second one is that you acidify with dilute nitric acid and then add aqueous silver nitrate. And if white precipitates form, what does it represent? It means that it is chloride. Okay, now we have come to the conclusion that the positive ion is aluminium and the negative one is chloride ion. So our correct option is aluminium oxide, aluminium chloride. Third is acidify with dilute nitric acid, then add aqueous barium nitrate. But the solution remains colorless. So that means that sulfate is not present, because if sulfate were present, that it must have given white precipitates to us. So that means our answer is aluminium chloride. So students, these were the MCQs from May-June 2025 paper. I hope this video helped you understand the concepts and common mistakes that the students make in MCQs. If you found this useful, don't forget to like, subscribe and share Chemicate with your friends, and tell me in the comments which questions were the trickiest one for you. See you next time in the next video. Until then, stay charged with Chemicate. Allah Hafiz.